Hi, this is Jon Leslie. Let me show you why running QA in Favro can make such a big difference. First off, what we're looking at here is known as the Agile Triangle. As it clearly shows, there's two types of quality in any software product. Extrinsic quality, or value to the customer. Does the product do what the customer needs or wants it to do? And intrinsic quality. Does the software work, essentially? Does it do what it was designed to do, relatively bug-free? The goal of any development team, any technology-centric product company for that matter, should be to maximize both intrinsic and extrinsic quality while constantly balancing against the constraints of cost, schedule, and scope. Another goal of product development teams should be both to detect and fix bugs as early as possible. As you can see in this chart, the relative cost of fixing bugs at each stage goes up drastically as we move from requirements and design through to actual development, integration and systems testing, acceptance testing, and the worst case scenario, the bug is released and is detected by the customer in production. Of course, one of the many benefits of Agile is its focus on iterative and incremental development, which shortens this development lifecycle, ensuring that the all-important direct customer feedback is received as early as possible. Even with shorter development iterations, the best way to ensure extrinsic quality, the value the customer perceives, is to create and maintain a product backlog like this one we see here in Favro. Here we have this online reservation app backlog. With Favro's unique ability to break large things like this restaurant search theme down into smaller things like these epics, all the way down to actual features or user stories, something that can be committed to an iteration and actually completed and delivered within that iteration. What this allows you to do is to prioritize at all levels, as you see here. It also allows you to size, which helps the product owner or customer proxy decide exactly what features to work on first, and the features to not work on at all, that provide no value to the customer. In this way, we're actually stopping value-based defects before they even happen. We're not even going to start working on something that the customer doesn't even need or want. We can also couple this directly on the card with advanced Agile techniques, such as definition of ready. Is this user story actually even ready to begin working on? Is it independent of other features? Is it negotiable, valuable, estimable, small, testable, etc.? Along with acceptance criteria, figuring out exactly the requirements of what needs to be done for this particular feature to be accepted by the product owner and ultimately by the customer as a valuable feature. By taking these simple steps, we're ensuring that we maximize extrinsic quality and the value that the customer ultimately receives, and also catching extrinsic defects before they even begin development. During Agile coaching engagements, a frequently asked question is who owns quality? And the answer is simple. It's the entire team, the entire development team, including if it's a Scrum team, the Scrum Master, and the product owner. On any high-performing product development team, quality should be built into the development process and the team itself. This can be a combination of pair programming, embedded QA, automated testing, and T-shaped developers. T-shaped, as you see here, means all team members have both a deep functional or discipline-specific expertise and a broad ability to work outside of their specialty, ideally with a focus on QA. Once development begins on committed product features, both development and quality assurance should constantly overlap throughout the iteration. If possible, all defects should be detected and fixed within the same iteration. For example, if we take this very high priority feature, also known as a user story, advanced results map, and drag and drop it, committing it to the sprint backlog, maybe during sprint planning, eventually this particular feature is going to be worked on by the team. They'll pull it into in progress. When it's ready for QA review, it can be pulled into QA review. where it's automatically tagged, maybe automatically assigned to the QA analyst or the embedded QA person on that team. And say during the course of that embedded QA review, they do find a couple of bugs, represented here, which could be added to the same iteration sprint backlog. Again, these should be fixed within the same iteration. So we'll tag these both as bugs. And what we can also do is we can actually link the user story or feature card back to those bugs. We have this one. And then we'll add the second bug. Making it very clear to the developer what bugs were found for this particular user story that need to be fixed, again, within the iteration. If these are very minor or straightforward bugs, they could be added directly as tasks, as you see here, to the card itself. Defects that are not found within the development iteration are known as escaped bugs. Escaped bugs are undesirable for obvious reasons, especially if an escaped bug makes it into production and is detected by the customer. Of course, some escape bugs are inevitable and should be managed and resolved using the same collaboration platform as bugs found within an iteration. In this case, in Favro, we have this internal QA or DevOps collection. Here they can have their own board, where if a feature is ready for release, from a development team perspective, it could then move to this board to be integrated to the system testing, regression testing, acceptance testing, eventually staged for release. So say a bug is detected at one of these stages. You can simply flag this particular user story as defects found, and now within this same collection, if we open up the backlog panel over here on the left, this particular example internal QA collection contains this escaped bug backlog board. Here in a Sheets view, you can see we can add things like severity, repro rate, bug priority, the release that this particular bug was found in, so on and so forth. This bug backlog is populated with bugs found by internal QA, automated continuous integration, deployment testing, and even external QA, which I'll show you in a moment. To create and track and visualize your own custom bug flow, it's easy to switch this particular board from a Sheets view, as we see here, to a Kanban view, where we can see those same bugs going through their bug fix flow from found to eventually fixed and closed. These escape bugs will travel through their own flow, maybe from opened to bug verified to triage. And in this particular example, when a bug does reach the triage stage, it's automatically being added via Favro automations to the appropriate development team's product backlog for fixing. In this case, this particular bug was automatically added to the online reservation app backlog of the development team we previously saw. If I open this particular card, you can see here via relations that from an internal QA perspective, we're obviously at the triage stage, and this bug has been added to that product development team's product backlog. If I click this, I can navigate directly from here to see the progress of that particular bug from a development team perspective. Once in the product backlog, the product owner or the customer proxy can easily prioritize bugs alongside features for commitment to upcoming iterations. Since this is a crash, it'll probably be prioritized as very high. And to commit this bug to the actual team sprint or Kanban board, it's the same thing as with the features. It's simple drag and drop like this. This will eventually be assigned and pulled into in progress, maybe like this. And again, thanks to the power of Favro relations, the internal QA team, from their collection again, we'll go back to it there, we'll be able to see that this particular bug is currently in progress by this development team, and it's been assigned to this developer, so they can then move this forward in their own workflow from triage to assigned, like so. Suppose your organization does work with external QA. In that case, it's a good idea to create a separate collection specific to them, such as this sample external QA collection in Favro we see here, where external QA team members can either be added as external guests or what are called external members, where they have more permissions, bringing them closer to your internal QA teams. That external team can have their own flow, something similar to this, and they can also have their own backlog for the escape bugs that they detect. Once more, using the power of Favro automations, as a bug is pulled from open to maybe bug verified by that external team, like so, you can see here that it automatically added it to the internal escape bug backlog, to the bug verified stage. I can quickly jump back over to the internal QA collection to see that. And since the boards in Favro can exist in multiple collections at the same time, we're able to actually pull in, as you see here, that external QA team's bug backlog and also that external QA team's board, as we saw in their very own collection. Essentially turning this into an internal QA dashboard, so to say. Sometimes integration with pre-existing bug tracking tools such as Jira is unavoidable. In these cases, Favro has a native two-way Jira integration. Bugs entered in Jira will automatically be added to a Favro board and vice versa. As you can see here, for example, we have this Jira bugs backlog, which is being fed primarily from Jira. As soon as a bug is entered there, it automatically appears here in Favro. If I open up one of these bugs that originated in Jira, you can see that team member assignments are mapped, as well as descriptions, and also there's a link provided back to the bug in Jira. The movement of a Jira bug from stage to stage can also be synchronized between both tools, as this particular bug moves from sprint backlog to in progress to QA review, for example. That same movement can automatically be tracked on a Jira board. In summary, every development organization has its unique way of tracking and resolving bugs. Favro's flexibility makes it possible to map any existing bug flow to the app, maybe starting with an integration to a current bug tracking system and migrating over time. Regardless of your unique way of working, the focus should be on detecting defects and resolving them as early as possible. As we've discussed, this is best achieved by having all product development stages take place on the same platform. In the spirit of continuous improvement, your quality assurance process will evolve. Again, Favro's non-centralized, team-empowered design makes implementing these process improvements effortless, whether they happen in product management, development, DevOps, or QA. Thank you, and best of luck with Favro.